Alright, again, we are in Unit 1, we're in Chapter 5. We are cycling back through here again, talking about variance again. Variance is the dispersion, right? Its dispersion is often the result of various changes happenings, right? For example, consider the motion of microscopic particles suspended in liquid, right? The unpredictable motion of any particle is the result of many small movements in various directions caused by random bumps from other particles, right? Again, what it's basically saying is there's subtle movements that are happening in particles, right? Small little movements, right? Consider ping pong balls drop straight down from a very, very high tower and subjected to chance in the air of something happening to them. We can measure the deviations from a center spot on the ground to the spots where the balls strike to see kind of how far they all bounce away, is what we're saying. As the height of the tower is increased, right, the average of the squared deviations increases proportionally. Variance is basically trying to measure the dispersion from the mean, or the average, due to a multitude of chance effects. All right, how far away is it from the mean, right? The formula for population variance is this. That's the variance. Formula for population variance. The formula for sample variance. Okay. Notice that for the most part, everything is the same. We talked about this before. Population, 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 but this is sample. All right, we go -1, all right, to make it more of an overestimation when we're talking about this stuff. On your tip, most calculators give the standard deviation. All right, so this must be squared in order to find the variance. Just things to remember, right? Take a look at this example. All right, the points per game during the 2014-2015 season of the Golden State Warrior players were this, right? So here are the, points per game. So no big deal, right, for their players. What was the variance of them? Okay, I mean, I'm just looking here at the data, scanning through it. I have someone who barely scored a point a game, and then you probably have someone who is probably like Steph Curry, scoring close to 23.8 points a game on average. So let's use the calculator, plug this data in, and we go to Stat and Edit, right? We plug all of our data in. Just make sure you clear it out first to plug in your data. Press the arrow over, do one variable stats, and basically we find out that the average person on the team is scoring 8.5 points a game. Now, that one person, that's way off. They barely scored a point a game, but then so was the other one. The other end of the spectrum, someone like maybe Steph Curry was scoring 23.8 points a game. Completely off, right? Point is, that right there, that is the population, and it would be because that's their team at the time. So their population is all the players who were on their team, and that's right there. And we square it. Remember, we use that, even though it's a sample. It was just a sample of those players, but we could use population because we're talking about the entire population of their team, looking at it from that standpoint, not the entire NBA. And when we square it, we get 40.17. All right. And the point is, that is the variance, all right, of what we're looking at. All right, we're finding the variance of what we're looking at. The formula for population standard deviation is this. Now, variance isn't used a ton. Standard deviation is used a ton, okay? It tells you how far from the mean each item basically is what your standard deviation is, okay? And it can help you find outliers, things like that. But the point is the population standard deviation, all right, and the sample standard deviation. Again, same idea, all right? Population, 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 and then this is sample, and sample, remember, it's an overestimate, so we do -1. And again, if I'm moving too fast, you got to make sure you pause the videos to write the stuff down. Now, while variance is measured in square units, standard deviation is not. It's measured at the same units as everything else. Standard deviation, right? So, the deviations between these two are called residuals. We're going to get to that, especially in Unit 2 more than anything else. Those are called residuals, all right? And S is a typical value for the residuals, okay? So that distance between there, that is called a residual. While S is not the average of the residuals, right? Standard deviation S does give a measure of the spread of the X values around the mean. Okay, it gives you a measure of the spread around the mean. All right, fact, the average of the residuals is always going to be 0. Okay, the average of those residuals that you get, always 0. All right, if you take all the residuals together when you subtract them, all right, and then you average that out, you will get 0. So take a look at this example. The number of calories in a 12-ounce serving of 5 popular beers. There's the calories. All right. Let's plug these to find the standard deviation. All right. So go to Stat, Edit. All right. We clear our list out, and then we plug them all in. All right. We got this down by now. Press the arrow key over and highlight and do one variable stat. Now I have my mean, right? My mean is 154.2 calories, basically. And since these are samples of beers, because I only just took 5 of them, I'm going down to the sample standard deviation here to get 44.076 is the standard deviation, right? So if the problem is a sample, we use the sample mean, sample variance, sample standard deviations, etc. in the calculator. Prior, we mixed and matched a couple of the examples a little before, because sometimes when it's uncertain, what are you supposed to do? Do I know that it's the entire population, or do I know that it is a sample of it? In the one that we did with rainfall, you could probably argue that we used the population because it was the entire year that we used, instead of taking a couple months from that year. But did we do the years before, every year that we could possibly think of? So it depends on how you want to. If you're fuzzy on it, just use the population. But more than likely, there's more than 5 different beers that exist. That's why we use a sample. All right. Taking a look at simple rankings, percentiles again, z-scores, things like that. We have seen several ways of choosing a value to represent the center of this distribution, right? We also needed to talk about the position at which it is located. We did that with some percentile rankings as well. In some situations, simple rankings, all right, just having a simple rankings, like that's first place, second place, third place, that's just like a simple ranking. In other cases, for example, evaluating college applications may involve positionings according to where you were, your class rank, your percentile ranking, right? There are situations in which positions can be specified by making use of measurements, all right, of the central tendencies as well as a variability. So you have simple ranking, which I just stated. That involved arranging the elements in some type of order and noting where they are in that order, right? That's just simple. Like he was first overall, he was second overall, kind of like a class rank in a way. Percentile ranking, right, is involved just a percentage of all values that fall below the value that you are looking at. They all fall below that. A z-score, all right, we went over that before. That states very specifically by how many standard deviations a value varies from the mean. All right, so how does it vary from the mean? So for example, it is recommended that the good cholesterol, high density lipoproteins, or HDL, be present in the blood at levels of at least 40 milligrams, right? Suppose a 50-member high school football team are all tested with the results. So here are all their results. Now, if we're going to do this example, you're definitely going to have to pause, write these all down so that you can get the list, plug them all in on your calculator. Okay? So you plug them all in your calculator, and it says, what is the position of the HDL who scores a 41? All right? So you got all these. What is their position? So here's what you would do. Plug these numbers into our calculator by Stat, Edit. Make sure you clear everything out, right? The arrow key, so I plug them all in. Then press Stat, arrow over to one variable stats. All right, and here's what we get. I got my mean, I got all this stuff taken care of, right? It's all good. But for a simple rank, we would need to put the numbers in order to make this work. So I got the middle. I know what the middle value is. The calculator technically put them all in the middle for me, so I know what is the high, I know what the low is, I know the middle. Like I know all of that, but do I know where 41 is? Because I wanted to know where that is in rank. So I'm not going to torture you here, all right? I will just tell you, as they go in order from low to high, there are 31 higher HDL levels on the list than 41, right? So if you were to arrange these in order, there are 31 that are higher than it. Therefore, if there were, and you can use the calculator, it will reorder these and rank these for you, and then you could look at it. But there are 31 higher than number 41, right? 31 higher than the number 41. So 41 then, if that is 31 higher, it is the 32nd out of 50, right? It's the 32nd out of 50. If there were 31 higher, then it's the next one, okay? Simple ranking is just finding how many are better. Simple ranking. How many were better than me? That's all you're doing. How many were above me? Well, there were right here, the number 41. There were 31 higher than me. So that's all you got to do. The percentile ranking works this way. There are 18 HDL levels lower than that. So the percentile ranking would be 18. So simple ranking is like the opposite. Simple ranking is how many were above. This one is how many were lower, all right, than what you are. Percentile ranking is just the other way around. Simple ranking, how many were higher. Percentile ranking, how many were lower, right? And you end up with that exact number. To find the z-score, we need to know the sample mean and sample deviation in order to make this work, which we do because we plugged all those values in on the calculator. If you look back at what we plugged in on the calculator, I could find that for 41. I could find the z-score because I knew we had 41. This was the mean of our sample. This is the standard deviation of our sample. So I could see that 41 was actually below the mean, all right, by negative 0.413. Again, simple ranking, it's easily calculated and understood. It's above. You find that mark, how many were above, right? We know what it means for someone to graduate second in a class of 435, right? If you're second, there's only one above you. You're second in the class. Only one person was above you. Only one person was better than you if you're second. So take the next number after that, and that's your place if you're doing simple ranking. Out of a team of 30 baseball players, you have the 17th best batting average. All right, that means 16, right? 16 players were better than you. All right, that's what it means. You were the 17th. 16 were better than you. Okay? Percentile ranking, this is another ranking to tell position and can be helpful to compare positions with different bases. All right, we can easily compare a ranking of 176 out of 704 with a ranking of 187 out of 935, because what we'll just basically do is we'll find the percentages of each. The first percent, that was 75%, because we're looking at everything below, and that was 80%, right, which is another rank. So all you're doing is trying to figure out the rankings, noting that the first has a 75% ranking and the second has an 80% ranking, is all that you're doing. Okay. Percentile rank is also useful when the exact population size is not known or relevant. Okay. We'll continue here with some more percentile rankings when we come back.